Welcome to The Explainer. Today we are diving deep into the science of learning to equip you with a really practical, evidence-based toolkit to help you master literally any subject efficiently. Whether you're a student facing down exams, a professional picking up a new skill, or honestly just someone who loves learning, the strategies we're looking at today are drawn directly from cognitive psychology and neuroscience to help you learn smarter, not harder.
Okay, let's kick things off with a pretty tough question. Are you studying the wrong way? Think about your last major study session. Did you spend hours rereading chapters, meticulously highlighting text in neon colors, or maybe waiting until the last minute for a massive cramming session? If so, you are definitely not alone. A whopping 92% of students rely on these exact habits, but the science tells us these are actually some of the least effective ways to learn.
The reason these methods fail is a trap cognitive scientists call illusions of competence. When you read a highlighted sentence for the fourth time, your brain recognizes it. It feels easy, so you think, awesome, I've learned this. But here's the catch. Recognition is not the same as recall. The moment you close the book, the forgetting curve kicks in. When the material isn't right there in front of you, that illusion totally shatters.
So here is our roadmap for today. We're going to cover 1. The science of learning, 2. Spacing and retrieval practice, 3. Mixing and chunking information, 4. Deepening your understanding, and finally, 5. Beating procrastination and illusions. Let's get right into it.
All right, part 1, the science of learning.
We really need to shift our mindset away from those comfortable habits we just talked about. Notice the contrast here. Passive methods like rereading and cramming feel super productive, but they demand very little cognitive effort. Active methods, however, things like self-testing, introduce what experts call desirable difficulties. Yes, they feel harder, but that friction is exactly what creates an enduring trace in your long-term memory.
Now, educational psychology data shows us that not all active techniques are created equal. Spaced repetition takes some planning, but it's totally unmatched for memorizing facts. Elaboration, on the other hand, helps you deeply understand concepts. Dual coding is incredible for grasping complex systems, while the Pomodoro technique is just a really simple, elegant tool for managing your time. The big takeaway here? You've got to pick the right tool for the job.
Moving right along to Section 2, Spacing and Retrieval Practice. These are honestly the undisputed champions of studying.
Listen, if you only take 2 things away from this whole explainer, please let it be these next 2 concepts. First up is spaced repetition. Instead of studying a topic for 5 hours straight the night before a test, study it for 1 hour a week for 5 weeks. Revisiting material at optimized intervals absolutely prevents cognitive overload and effectively flatlines that pesky forgetting curve.
So how do we actually do this? Well, a highly effective, tactical way is the Leitner system, which was developed back in the 1970s. You just organize flashcards into boxes. Every single card starts in box 1. If you get it right, it graduates to box 2. Get it right again? Boom, box 3. But if you miss it, no matter where it is, it goes all the way back to box 1. You review box 1 every day, box 2 every few days, and box 3 just once a week. It forces you to spend your precious time exactly where you're the weakest.
But hey, spaced repetition only works if you're doing the right thing during those sessions. And that thing is retrieval practice. This means closing your notes, shutting your laptop, and actively forcing your brain to recall the facts. Whether that's taking a practice test or just jotting down everything you know on a blank sheet of paper, the actual struggle of retrieving the information is exactly what cements it into your memory.
Okay, Section 3, Mixing and Chunking Information to Manage Your Cognitive Load.
To manage that load, let's contrast blocked practice with interleaved practice. Blocked practice is doing 20 math problems of the exact same type. Sure, you get into a groove, but you aren't really learning how to identify the problem type out in the wild. Interleaved practice, though, mixes them up. You do a geometry problem, then an algebra one, then maybe statistics. It feels frustrating at first, for sure, but it triggers the contextual interference effect. By constantly forcing your brain to switch gears and choose the right strategy, you achieve true mastery instead of just blindly going through the motions.
Now, when you're dealing with vast amounts of data, you absolutely need chunking. Our working memory can only hold so much at once, right? Chunking involves breaking dense material down into digestible, bite-sized parts. Say you're studying the human body. You don't try to memorize every single bone at once. You chunk it by the upper body, then the arm, then the hand. By organizing data into interconnected pieces, you make it far, far easier for your brain to access and process.
Which brings us to Section 4, Deepening Your Understanding by Connecting It All to Reality.
To really move past just memorizing random facts and connect abstract theories to reality, we use something called dual coding. This technique recognizes that our brains process visual and verbal information through two completely different channels. By combining text with a diagram, a mind map, or even color-coded notes, you are literally creating multiple pathways to the exact same memory. During a test, if you totally blank on the verbal definition, you might still be able to retrieve the visual diagram from your memory, which then beautifully triggers the words.
Another awesome way to deepen your understanding is by using multiple concrete examples. Let's look at the abstract concept of scarcity. If you only learn one example, like airline tickets getting expensive right before a flight, your brain might just associate scarcity with airplanes. But if you add concert tickets and then add a completely different scenario, like water rationing during a severe drought, you force your brain to identify the underlying principle linking them all together, that a limited resource increases in value.
And if you really want to test if you've truly grasped a concept, use the Feynman technique, named after the famous Nobel Prize-winning physicist. You choose a concept and you try to teach it out loud in simple layman's terms, almost as if you were explaining it to a child. The very second you have to rely on confusing jargon or you start to stumble, you've instantly identified a blind spot in your own understanding. So you go back to the source, simplify it, and try again.
Now, what if you're staring down a massive, completely intimidating textbook? The SQ3R method is going to be your best friend. Instead of painfully slogging from page 1, you first survey the chapter headings. Then you formulate questions based on those exact headings. Only then do you read to actually find the answers. Afterward, recite the concepts out loud, and finally, review the material later. It literally transforms a passive, boring slog into a highly engaging, retentive process.
All of these strategies really feed into one big idea: elaboration. True elaboration is all about weaving new facts tightly into your existing knowledge web. You do this by constantly asking yourself how and why things work. Don't just accept a fact, interrogate it. Relate a new historical event to the political climate of the time, or relate a new biological concept to something you already know about your own body.
Finally, we hit Section 5, beating procrastination and illusions. Listen, you can have all the fancy cognitive tools in the world, but if you can't focus, they just aren't going to help. The science actually shows us that our brains operate in two distinct modes. The focused mode is when you are intensely concentrating on a specific problem. But your brain also desperately needs the diffuse mode, a relaxed, broader perspective where you aren't actively trying to solve anything, like when you're taking a walk or having a shower. Believe it or not, this diffuse state is actually when the brain makes its most complex, creative neural connections. To master tough subjects, you have to allow your brain to toggle back and forth between both.
But getting into that focused mode? Yeah, it can be tough, especially when those zombies of procrastination are knocking at your door. Enter the Pomodoro technique, your ultimate weapon here. You pick a task, set a timer for exactly 25 minutes, and commit to pure, focused work. Then, you take a 5-minute break to let your brain happily slip into that diffuse mode. By focusing entirely on the process of studying for 25 minutes, rather than the terrifying end product of, say, writing a massive paper, you totally bypass the anxiety that causes you to procrastinate in the first place.
Look, putting these techniques into practice definitely takes effort. It requires moving past those comfortable illusions of competence and fully embracing desirable difficulties. But as the research clearly shows, no matter your current skill level, understanding how your brain works and applying these active learning strategies will completely revolutionize your capacity to learn. Change your thoughts about how learning happens, and you quite literally change your life.
So, I want to leave you with a bit of a challenge. Which strategy will you implement in your very next study session? Don't try to do them all at once. That's way too much. Just pick one. Maybe it's the Pomodoro timer. Maybe it's creating some Leitner flashcards. Or maybe it's trying out the Feynman technique. Take that first step, challenge your brain, and just watch your understanding soar. Thank you so much for joining me on this explainer, and happy learning.